So that is 9.1. So now we are going to focus on 9.2, which is heat transfer. Heat transfer. Thermal energy flows from a higher temperature to a lower temperature, which we've already talked about. Heat transfer. There are three ways that heat flows. We're going to talk about conduction, convection, and thermal radiation. Conduction, everybody's familiar with. You touch something directly and you, ooh, hot, ow, because it directly transfers the heat by direct contact. Conduction occurs between two materials at different temperatures when they are touching each other. Now, if they're at the same temperature, there's not going to be any heat transfer. You ever cook something and you stir it with a metal spoon and you leave it in the pan and then you come back and you go to stir it again and you can't touch the spoon because it's hot, because the heat has transferred to the spoon because of direct contact. Okay. So in order for it to transfer this way, it has to be a direct particle-to-particle contact here for the heat to flow through the items. And it's going to occur until they're both the same temperature, which we call thermal equilibrium. At that point, no heat flows at all. So if it's everything is room temperature, heat's not going to go back and forth. And that is the goal of all matter. Materials that conduct heat easily are called thermal conductors. Those that conduct heat poorly are called thermal insulators, and this is very similar to what we talked about with electricity. Here it says it's a down coat, a conductor, or an insulator. Some of you have down coats, some of you might have a down comforter at home. And think about, when you think about down, down is the breast feathers of a bird. When you see birds that don't fly south in the winter and they're sitting outside in the trees or on the telephone wires, they puff themselves up. What they're actually doing is placing air in between their feathers. And these feathers trap it, and that air between these feathers acts as a good insulator. Okay. Air you find as a good insulator, double paned windows. You look at your windows at home, there's never usually, unless you have an older home, it's one pane glass. Double pane means there's air trapped in between. It's used as an insulator. Styrofoam cups. It's a polymer that they pump full of air. You put hot beverages in it. It's the air in that material that is actually being the insulator. There are different other items that are insulators as well. Wood and plastic. You see them used as on pots and pans at home. But then you see your conductors. Aluminum, copper, gold. Typically most of your metals are very good conductors, as we saw with electricity as well. The other way for heat to transfer is through convection. This is a transfer through the motion of matter such as air and water. So it's not just water, it could be any liquid and it could be any gas. If you look at water, water at the bottom of the pot rises to the top and replaces the cold water. So basically, cooler things are more dense, so they tend to sink. So they go to the bottom, they get heated up, they spread farther apart, and they rise, and heat rises. And you've learned this in fire safety. Where do you crawl on the ground when you're trying to get out of a house? They want you on the floor because heat rises. You have ceiling fans in your house to kind of help push the warm air down because your heat vents are on the floor, and that's for a reason. You might have a lava lamp at home. It does the same thing this way. Think about when you boil noodles. What happens to the noodles? They go up and down. And this is all due to convection currents. So you see this in your house. So you have your cool air here and your warm air at the top. So you'll have a cool air intake and your warm air, and your house is built so it distributes through the house, because otherwise you're not going to have the heat where you want to have the heat. And the last way that we're going to talk about is heat transfer is radiation. Heat from the sun is transferred to the earth by thermal radiation. All energy the Earth receives from the sun comes from thermal radiation. The higher the temperature of an object, the more thermal radiation it emits. And you can see that here in this graph. So as the temperature goes up, the power that's emitted goes up. Thermal radiation is also absorbed by objects. The amount of thermal radiation absorbed depends on the surface of the material. Dark surfaces absorb most of the thermal radiation they receive. Silver or mirrored surfaces reflect thermal radiation. You'll see that, like, dark surfaces, think about in the summer. Don't wear a black shirt, wear a white shirt, because the white's going to reflect. You see cars in the summer use the little sunshades that are silvered or mirrored to reflect the thermal heat out of the car so your car doesn't overheat. This is the same thing. Things will absorb thermal radiation and they will conduct heat at different rates too. So think about when you stand on carpet. It feels warmer than standing on tile, even though you may have them in your house. They're at the same room temperature, but they feel different temperatures, but it's just due to the way that they conduct and radiate heat. Heat transfer with winds and currents. A thermal is a convection current in the atmosphere. So we see this in nature. When a surface like a road absorbs solar radiation and emits energy as heat. That you will see that kind of as a mirage. So that's another example. So the warmed air molecules gain kinetic energy and rise. Colder air is forced aside and sinks. You'll see birds catching thermals, and they use less energy to fly around because they don't have to flap their wings because they rely on the rising warm air to push them up. This is the same reason why we have weather patterns, and that leads us to our hurricanes. So we have global winds. There are giant convection currents in the Earth's atmosphere, the global wind pattern. And the Earth's rotation also causes surface ocean currents to move in large circular patterns. So the ocean has convection currents. The air around the Earth has convection currents. Within the Earth, the rocks have convection currents. And that's why we have the rock cycle. So you see the method of transferring heat all around us and everywhere.